Welcome back to Science at the Museum. My name is Sierra. I'm an educator-performer here at the Denver Museum of Nature and Science. Today we will be learning, listening, playing, and wondering all about animals. And our super science skill will be measuring. To measure is to use numbers to count how tall or short something is, how big or small, how heavy or light. It helps us wonder, how old is that? How far away is it? So let's kick it off with Amanda and Franklin, our chipmunk and raccoon hosts, to get started.
That was a lot of purring.
That was intense.
I'm exhausted. But no time to be exhausted. We've got learning to do. I am Neotamias quadrivitatus, also known as timber tiger, also known as seed stasher, also known as just Amanda. And I'm your chipmunk host for today.
Hi everyone, my name is Procyon Loader, aka Trash Panda, aka Basura Bandit, aka Forage Finder, aka Mapache, aka Franklin Cruz, and I am your raccoon host for today. Now,
Sorry, what are we talking about today, Franklin?
well, Amanda, that's exactly what I was gonna ask you about, because we have this really cool thing to talk about called collections. But to be the most honest, I don't have the best definition for collections. Do you have a good definition?
Well, I mean, if you want to get scientific about it, they're actually called zoological specimens. But that's a super scientific term. Yeah, here at the museum, we just call them collections. And these collections are usually animals. They can be artifacts from people that lived long ago. And today we're going to be learning about the animals. So we use animals collections at the museum to help us learn all about them without having to be in the wild. So some of these collections are really old. Some of them are extinct. So we use these collections to help us learn more about them.
So what you're telling me is these were things that at one point were alive. They're no longer alive, but they help us learn about the living things.
Exactly. It's called taxidermy. So we use animals that were alive at one point that are not alive anymore to make things look more realistic.
Now, one thing I do know about collections is they have to last a seriously long time, which means you have to be super careful about where you store them. Do you know where we store collections here in the museum?
Here at the museum, we have just like tons and tons of collection space. And a lot of those spaces you can't actually get to. I can't get to them. You can't get to them. Visitors that come to the museum can't get to them without a special badge. So
Great.
I think we should go take a visit. What do you think?
It sounds like a really magical spot. I'm down.
Let's do it.
Let's go.
All right.
Behind these doors lie spellbinding adventures, secret chambers, and fantastic beasts of a special kind, all brought to life with a little magic. A little museum magic. Welcome to the Denver Museum of Nature and Science. Like many museums, this museum isn't just home to exciting exhibitions. Behind the scenes, we house over 4 million items in our collection. That's right, over 4 million items, including everything from sherds of ancient pottery, prehistoric fossils, meteorites, and much more. There are so many items in the collection here that less than 1% of all of our specimens are on display. The rest are stored in special spaces hidden throughout the building. Like this one. So why do museums keep so many collections items hidden away? why not bring them out for all to see? For one, some items might be culturally sensitive, one of a kind, or easily damaged. Museums have a responsibility to care for their collections in perpetuity. That means forever. Sometimes it's just too risky to have something on display. In addition, many scientists use museum collections to make new discoveries. Scientists might analyze DNA, compare fossils found in different areas, and see how a species has changed across time, all with help from museum specimens. Keeping these items in perpetuity means making sure that these research collections are around hundreds or even thousands of years from now. When we say forever, we mean it.
Really? Collections witches again.
But that doesn't mean that 99% of museum collections never see the light of day. Quite the opposite. We know that learning in museums is made more fun by getting to see and even touch real objects, and a team of 2 wonderful witches cares for those fantastic beasts that emerge to enchant our museum guests. Let's go meet them. That usually works. No? Open! 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 Open!
Hi, Talia. You want to come in?
Hi, Colleen. Yeah, can I come in?
Yeah, come on.
Okay, thanks. It usually works. I don't know what the deal was. This corner of the castle is called the Figgins Collections Range, and it's home to the museum's education collection. This special space houses thousands of items, everything from bears to wolves to bighorn sheep to Evelyns to Colleens to astronauts and so much more. While these collections items are stored just as carefully as our research collections, there's something special about the curiosities in these cabinets.
Hey everybody, it is Amanda. I am here to do another edible science lesson with you guys. This one's going to be a little bit weird and a little bit different, but we'll get into that in a little bit. Now, Franklin already told you guys what an animal is, right? An animal is a consumer, which means it needs to eat plants or another animal in order for it to get energy, just like we do, right? We need to eat food so that we can get energy. Now, we pull that energy out of the food and we're left with waste. So if we're eating, or if an animal is eating, it also has to get rid of the waste, which means it's gotta poop, right? And it turns out we can learn a lot from animal poop. In the natural world, we call that scat. That's the scientific term, scat. But it's also really fun to say poop, right? How often is it okay to say poop around your house? So we can actually learn a lot from that animal scat. If we look at that scat really closely, we can tell what an animal was eating. We can also tell how many animals were in the area. I'm going to show you guys some bear scats. Bears are omnivores, which means they eat plants and they eat animals. This is bear scat right here. If we were to look really closely at that bear scat, I want you guys to do that. What are some things that you notice in our bear poop? Yeah, maybe you guys see seeds, maybe you guys see bits of grass or bits of leaves. It's harder to see, but there's some white stuff in there. When we see white, almost powder-like substances, that means that that animal was also eating other animals. We can see evidence of fur in this poop too. Maybe it was hard for you guys to see on camera. So we're gonna do a little activity where you guys can make your own animal scat out of candy. All right, I want to see if you guys can figure out what kind of candy I used to make this animal scat. So we're going to head on over to my animal scat chart. Check it out, animal poop. Now we can tell by the shape and the size of the poop what animal left it. All right, so mountain lion poop, they're carnivores. All right, so you might see big kind of square ends on mountain lion poop. It's going to be, this one's about the size of my thumb. It may even be bigger if you see it out in the forest. So if you live in an area where mountain lions hang out, you can go out and look for mountain lion poop. You can see evidence that there was a mountain lion around. Elk are really popular. They're really, well, popular. They're really common in Colorado, right? And they leave behind these big, round kind of balls of poop. They are herbivores, they're plant eaters, right? And so they're gonna leave little fibrous balls of poop. Coyotes are omnivores. They eat a little bit of everything. I like to think of them as opportunistic eaters. You'll see coyote poop, it almost looks like white or hairy. You may also see evidence of plants or berries in it, but they poop and they have kind of like this pointy end to them. And coyotes are sometimes easy to spot because they live in all different types of environments, from urban environments to grasslands to the foothills. Down here is rabbits. They're little animals, so they're gonna leave little poops, little balls of poop. Some of you may have seen this kind of poop in your yard. It looks like elk poop, but a little bit smaller. Ooh, bear poop. Bear poop you're gonna see, you guys already saw it on the screen, right? You're gonna see seeds in it, you're gonna see grass, it's gonna kind of be like big and flat. And then you have your deer poop here, which are a little bit bigger than rabbit poop and a little bit smaller than elk poop. If you see a lot of these little poop balls around, then maybe you can say there were a lot of deer hanging out in your yard. All right, guys, so fun poop activity that you guys can do at home with candy or some other edible material you have lying around your house. All right, enjoy.
Hey friends, Sierra here at the Denver Museum of Nature and Science, here to do some more exploration about how animals eat. We've learned that animals are consumers, which means they have to eat other plants and animals for energy. And as you know, if you eat something, you also have to get rid of the waste. A lot of animals do that by pooping, but some of them also do it by throwing up. I'm gonna explore some owl pellets, which are when an owl or another bird of prey eats an entire animal, but then can't digest the bones and the hair. So it gets clumped up in their stomach and they puke it up. It's kind of an amazing adaptation, and you can learn a lot about the diets of these amazing birds by opening those pellets up and seeing what's inside. So that's exactly what we're gonna do. I'm gonna put on some gloves because the ickiest sciences are my favorite sciences, but I still wanna stay nice and safe. And then I'll flip over to a camera where you can see my hands and our specimen, our owl pellet, as I take it apart. Let's check it out. So here is my owl pellet, sort of like a hairball that a cat might cough up. It's all wrapped up in foil, so I'm just gonna unwrap that like a present. So this is what they look like. It's mostly pressed together hair in a very tight formation. And I don't know if you can see, but I'm already seeing some little animal bones right here. They look like they might be ribs. So I'm gonna use this big old toothpick to carefully start to pry this guy open. You never know what you're gonna find. Owls tend to eat small mammals like little rodents, mice, shrews. They also sometimes eat smaller birds. So anything that can't be digested will end up in here. Wow, I see the teeth of a small mammal, like a little mouse. These red, long teeth. Let me see if I can get more of this skull out for us to see. The bones can be quite fragile. I'm trying to be very gentle here. Awesome. Wow, that is so cool. I can see some teeny tiny teeth right here. You've got the front teeth. This is where the nose would have been, and the eyes. And then these are the chewing teeth. This is the top of a skull. Awesome. Let's see what else we can find. I'm seeing a bone right here, very well preserved. Check it out. That is a shoulder blade. The very top of one of the legs. Oh, I found the bottom part of that jaw, at least one side. This is the lower jaw. That would go with this one. This looks like maybe another leg bone. Now, if people eat meat, we tend to carefully remove the bones or eat around them. Lots of animals do that too. But I'm sure you've also seen some animals, like these owls, that just swallow the whole thing whole. So this is their adaptation to get rid of that waste. Sometimes a dissection can feel a little bit like we're excavating fossils, like a paleontologist does. This looks like the back of that skull we found. Now we've got the whole thing. Both lower jaws, the upper, and then this part goes on the back. I wonder what this could be. And see if we can find any other discoveries here. Lots of little bones. There's another little jaw. So there's at least the bones of two animals in here. And there's the top. Now, I've done a lot of owl pellet dissections before, working as a science teacher and an educator here at the museum. So I know what a lot of these bones look like, but I didn't always know. I had to learn. And a great place to start is with a reference sheet made by scientists. So I have one of those here as well that can help me to figure out what all of these bones belonged to. This one that I wasn't so sure about looks a bit like this bone right here. I think it might be the hip of a small mammal called a shrew. Now, I could check this out all day long, but we've got lots more fun things to see and do. So let's pop back over and keep learning all about animals. If you'd like to do an owl pellet dissection, maybe your grown-ups could order some owl pellets online, or you could visit the museum, and sometimes we do them here as well. Thanks so much for checking out this amazing science with me. Let's head to the next exciting thing. See ya.
Hi everyone, it's Franklin, the raccoon host. And now we get to play a fun animal spotlight. We belong to a group of animals that have backbones. Do you know where your backbone is? I wonder. Backbone. It must be on our back. If we turn around and feel right in the middle of your back, right where my tail would be, you're gonna feel a really, really, really hard piece of your body. That's our backbone. one of these animals belongs to the same group. Can you tell which one? Right, it's the pufferfish. The pufferfish also has a backbone, but the scorpion does not. You want to know some other cool things about a pufferfish? They have a poison that runs through their skin to help protect them against other animals that might want to eat them. But they also have a really, really hard beak to break all kinds of shells because they also eat other animals. This animal is both a predator and prey. Versus the scorpion has no bones at all. It's got a hard exoskeleton to protect it against other animals that want to eat it. But it also has a really sharp stinger, which it uses to sting its prey when it's holding them down, because sometimes it wants to eat other animals too. It also has these really cool hairs all over its body to help detect things that are moving towards it. That way it can protect itself and sense other animals around it. Both of these animals are super cool, but which one do you like?
Franklin, thank you so much for showing us those super cool animals and all their adaptations. One thing I was wondering was how much do they weigh? Now, our pufferfish here, this is one of the smaller ones, and pufferfish weigh about 1/4 of a pound, this one, but they can get much, much bigger. They can also get much, much smaller. The emperor scorpion is the largest scorpion in the world, but it still only comes in at about 5 grams. Now that's hard to visualize, so let's use something that you actually might have at home. Sticks of butter. Now I said this one weighs about 1/4 of a pound, so that means this one weighs about 1 stick of butter. This one weighs 5 grams, so this one weighs just about a little pat of butter, like the amount of butter that you would put on your toast in the morning. Pretty incredible. I wonder how much the other ones weigh.
Fun fact, a pelican's pouch can grow to hold up to 3 gallons of water.
What's your favorite animal? Is it the speedy cheetah, the toothy shark, the tall giraffe, or the loyal dog? All of these cool things about animals that make them unique are usually what biologists call adaptations. An adaptation is like an animal's superpower that helps it survive in its habitat. But what's a habitat? That's where an animal lives that has everything it needs: food, water, shelter, and space to roam. Do you have a habitat? I like to think of my neighborhood as my habitat. It has places to eat, friends to meet, and my home where I can sleep safely even when it's cold and snowy outside. Yep, we humans have habitats and adaptations too. Can you give me a thumbs up? I can. Our thumbs help us communicate, climb trees, and use tools. Don't believe me? Try to use a pencil or a crayon to write your name on a piece of paper without using your thumbs. I'll give you a moment. Pretty difficult, huh? Now imagine trying to eat an apple or play a video game. Yep, these hands are just one of our amazing adaptations. Our hosts Amanda and Franklin have their own adaptations for their habitats too. I'll let them tell you.
Hi everyone, Franklin the raccoon host here, and we get to talk about one of my amazing friends, chipmunks. So I'm gonna invite my friend Amanda out so she can show us some of the crazy adaptations that a chipmunk has. Remember, an adaptation is something that an animal does or something an animal has on its body to help it survive in its habitat. Now, Amanda loves to live in a foresty, leafy habitat up in the mountains, but if she ever wants to find food, it's really hard to see your food when it's covered by all kinds of leaves. So Amanda has these really, really great adaptations. Number one being her nose. Can you find your nose? What do you do with your nose? Smell. But Amanda's sense of smell is so much better than our sense of smell that it helps her find acorns all through the leaves. But Amanda also has to be careful of other animals that want to eat her. So she has a really good sense of hearing. We have ears. What do you use your ears for? Hearing, right. If you want to make your hearing any better, you can actually cup your ear like this so you can hear more things. Try it at home. Now Amanda has to be super careful about the animals that might want to eat her in the forest. So she uses her sense of hearing to watch out. What do you use for your sense of hearing? Right, your ears. What do you hear? If you wanted to make your hearing any better, you could just cup your ears like this to see if you can hear more things. Now Amanda has to be both smelling and hearing so she finds food and stays safe. I'm gonna invite our little timber tiger to go looking through the forest and seeing what she can find with her nose. She found an acorn and stuffs it into her cheek. These little acorns are laying all in the ground, and Amanda has to use her great sense of smell to sniff them all out. She stuffs them in her cheek so she could take them home for later. Looks like Amanda's mouth is all full of acorns, so she's gonna scurry back to her home and stuff them into a tree so she can save them for later. What amazing adaptations.
So today we're learning about habitats and adaptations. And in the intro, you figured out what those are, right? A habitat is an animal's home. And an adaptation is something that an animal has on its body or something that an animal can do to help it survive in its environment. So let's explore a little bit more about my habitat and adaptations and our raccoon's habitat and adaptations. Here you see Franklin's habitat is an urban environment. We see raccoons a lot in the city. But Franklin has some really cool adaptations that help him find food. First of all, he is nocturnal, which means he's active at night. And because he's active at night, he has to have really good night vision. So he can see really well in the dark. But he actually relies a little bit more on his super sensitive paws to help him find food. So behind me I have a log. We're gonna have Franklin, our raccoon, crawl through that log and see what kind of food he can find with his super sensitive little paws. So Franklin, head on into our log. There he goes. He's a little big for this log. You finding anything in there? Oh, here he comes. Check it out! Franklin found a little frog in our log just by using his little paws. That's a pretty cool adaptation, isn't it?
Chipmunks in the forest and raccoons in the city. Next, Colorado scientists tell us about even more Colorado habitats. First, a little lagomorph called the pika from the alpine, the very tippy tops of mountains. And then the awesome endangered black-footed ferret from the grassland prairie.
What is small, brown, and lives high on the mountaintops? It sounds like the beginning of a cheesy joke, but it's actually the American pika. These tiny, adorable mammals aren't just cute to look at. They are living clues for scientists studying how climate change affects our planet. Let's talk about why. So what are pika anyway? They look a lot like hamsters, but are actually close cousins of rabbits and hares. Pika and their relatives belong to a group called lagomorphs, an order of small and furry mammals with 4 top front teeth that never stop growing. They love to eat their veggies. No meat for them. Pika are different from their cousins because they're really small, weighing only about as much as a baseball. And they live out here! If you've never seen pika before, you're not alone. That's because they only live in rocky environments like this one, at elevations above where trees can grow and where temperatures are cool year-round. Here in the Rocky Mountains, this environment is called the alpine tundra, and it's an extreme place to live. Up here at elevations like this, it's always cold and it's always windy. You and I might not want to spend every day up here, but to a pika, this place is paradise. Here in the Rockies, pika live in talus fields, or big rocky areas in the tundra. Pika are feisty, protecting their territory from neighbors with everything from scent marking to boxing matches to the fierce cry of the pika warrior. Pika have special adaptations to help them survive in harsh environments. Rather than hibernating like their marmot neighbors, they stay awake for the whole winter, building tunnels underneath blankets of snow and scurrying beneath the large rocks. Their small, round bodies, high metabolism, and thick coat help keep them warm. Pika eat only plants, but finding plants up here in the wintertime can be tricky. Pika prep by gathering grasses, flowers, and other plants into hay piles each summer. When the ground is covered in snow, pika can feed on that stored vegetation for up to 9 months. Hay piles are made of lots of different types of plants, and scientists have found that pika are careful collectors. To keep their hay piles from rotting too soon, pika harvest plants which decrease bacterial growth, making pika the cutest chemists around. It's also possible that as those hay piles break down, they generate heat which keep pika warm for the whole winter. Pika aren't just adapted to survive in the cold. They actually need to be cold. Adaptations like their warm and cozy coat means that pika can get too warm and can't survive for very long at temperatures above about 78 degrees Fahrenheit. We call pika habitat specialists, which means that they are so well adapted to environments like this that they can't survive anywhere else. This is why scientists want to study pika. As the climate changes, alpine tundra habitats normally cool enough for pika year-round might start to become too warm. As temperatures rise, pika have to move higher and higher to find elevations and temperatures cold enough for their survival. This means that their habitat is getting smaller, and we're worried that they won't be able to get from one mountain peak to another. And you can only go so high before you run out of mountain. This need for cold temperatures make pika an indicator species, a single species that can tell us how an entire ecosystem is doing. Scientists visit the same talus field each year to look to see if pika are still there or if they've moved on. If we don't find pika in places we used to see them, it might mean that the area is warming up too much and that alpine habitats are being affected by climate change. The good news is you can help scientists learn what pika have to tell us about our changing world. The Front Range Pika Project is a citizen science project which teaches the public to find out where pika live across Colorado. You can take part in this project and help scientists study these small but mighty mammals. Check out pikapartners.org to learn more. In the meantime, I'm off to go collect some data, but I hope to see you out here someday soon, peeking some pika.
Hey everyone, welcome back again. It's Trelaw and I'm at the Denver Museum of Nature and Science. We just had so much fun learning about the pika with Talia. You know, those little furry critters are fun to watch. And now we're going to introduce you to some other furry critters of Colorado. Maybe you've heard of BFFs before? No, not your best friend forever, the black-footed ferret. Joining us now are Sierra and Kim from the Fort Collins Museum of Discovery, where there are black-footed ferrets on display that you can learn about. So Kim and Sierra, take it away.
Thanks. Hi, everyone. I am so glad to have you all here with me today and with my friend Kim, and we are so excited to talk to you all about a very special animal that lives right here in Colorado, the black-footed ferret. Kim, do you want to tell us a little bit more about this animal?
Yes, well, there's actually a black-footed ferret right behind me who lives here at the museum. The black-footed ferret is one of the most endangered mammals in North America. They live from Canada to Mexico in 12 states. And Colorado is one of those states. And we actually have black-footed ferrets living in the wild in Colorado.
Oh, that is so, so cool. I see Stevie Nicks right there next to you.
She is. She lives here and in a display that houses actually 2 ferrets, Patty Ann and Stevie Nicks. Stevie Nicks is a special ferret, though. She was born blind. And so it's a good thing that she's here at the museum. She loves meeting the visitors that come, and they love meeting her because most Americans will never get to see a live black-footed ferret.
Very cool. Well, let's go ahead and share some photos of black-footed ferrets, and we can talk a little bit about where they live and what they do all day.
Sounds great. What family do they live in? Well, they're part of the Mustelidae family, so they're related to badgers and wolverines and minks and otters. We like to say this family has a lot of hair, big sharp teeth, and a bad boy on the block attitude. So if you can imagine holding a badger, what that would be like, actually holding a black-footed ferret is worse. They're so cute and charismatic, but they'll take your face off. They're pretty vicious.
It looks like you've got Stevie moving around there behind you.
Oh yeah, she's doing, that's her little ferret dance. She'll go round and round.
Well, here we've got a really great photo of a ferret so we can see him up close.
So they have the black mask, they have black feet, they have a elongated body because they spend their whole lives underground in those burrow systems hunting the prairie dogs.
Something else really cool about the black-footed ferret is the color of its coat. You can see here in this photo that it's standing against that dirt, that prairie dirt, and if you squint your eyes, you'll see that the ferret almost blends into the background. And it might be kind of hard to see against the dirt if you were a hawk flying above or a coyote running across the prairie. And that adaptation, having fur that's the same color as the area that the animal lives in, it helps them hide, and that's called camouflage.
So Sierra, would a black-footed ferret get eaten by a hawk or a coyote? Could that happen?
You know, it could happen. Even though black-footed ferrets are top predators down in the prairie dog burrows, when they're above ground, there are other predators that might try to eat them. So because of that, black-footed ferrets actually spend a lot of their time underground, where it's much safer and where their food the prairie dog lives. Now, I think there's a special term for an animal that lives underground that much. Maybe Kim can help us out with that.
Absolutely. If we go to the next slide, I think we have it. Fossorial predator. This is my favorite word out there. So, black-footed ferrets, they hunt prairie dogs underground. And so they're considered a fossorial predator. Well, where do you find fossils? You find them underground. And that's where they spend about 95% of their time underground. They rarely come up. They're nocturnal, means that if they do come up, it's usually at night. And they're solitary, so they pretty much live all by themselves. So the black-footed ferret. If you look close, I want you to see that you can see its 2 teeth hanging down. Black-footed ferrets have the longest canines of any mammal species in the world in ratio to their skull. And they use those 2 long, sharp teeth to kill prairie dogs, because prairie dogs are actually the same size as a black-footed ferret.
That's a pretty big hamburger.
Really, I think fascinating fact about black-footed ferrets is that they eat the whole prairie dog. They eat the bones and the skins and the eyes and the teeth and the claws. So kids, tonight when you're, eating your supper, be a black-footed ferret and clean your plate too.
So we talked a little bit about the different parts of the black-footed ferret earlier, but here you can really see their long, skinny body. When black-footed ferrets are maneuvering through the burrow, they need that long, skinny body to get all the way down the tunnels. They also have a very cool adaptation. They have a flexible spine, and black-footed ferrets can actually turn all the way around so that their head is by their back feet. but this helps them when they're navigating the burrow systems so that they can get around, even if the burrow or tunnel is too tight. Thank you so much, Kim, for telling us all about the black-footed ferret today. And thank you to all of you for joining us and learning with us. Remember, you can always visit the black-footed ferrets at Fort Collins Museum of Discovery, even if you can't come to the museum. We have a live ferret cam on our website, and you can check them out and see what Stevie Nicks is doing anytime.
And now it's time to do the black-footed ferret dance. Dance along with your new friend and try to keep up as they bounce, twirl, and wiggle.
Hang on, everybody. We've got some more fun learning coming up for you.
Oh, you caught my black-footed ferret dance. Anyway, Treloar said there's more learning to do, so let's head back to the museum, check out some flying animals, and conduct a little wing experiment. The next amazing adaptation we can explore is flight. Take a look at all of these animals. They have wings that help them soar through the air. But are their wings exactly the same? Let's look closely. One of the oldest examples we've ever seen of feathered wings in nature are on this Archaeopteryx from the late Jurassic. Taking a look at the bones and feathers reminds me a lot of these birds over here. If we look closely at the shape of each of these wings, they make me wonder if these two birds fly exactly the same way. We can also compare those to the bat, whose wings are made of long finger bones with skin in between. And even more different are our insect wings in the butterfly and dragonfly. So let's check out a fun activity that we can do to explore all of the wing shapes and how they impact how animals fly. So Amanda Franklin and I all built these cool paper gliders. They have different wing shapes, just like we saw with the animals we were looking at before. Let's see how that wing shape affects their flight. Ready? 1, 2, 3. So let's measure. Our bat had the shortest glide, just about 8 feet. The songbird went a little further, 8 feet 10 inches. Our dragonfly, about 10 feet and 2 inches. And our hawk really soared all the way to 15 feet and 7 inches. Awesome experiment.
Hey everybody, it's Amanda, your chipmunk host. I am here with Animal Spotlight number 2. I have 2 animals here that have excellent adaptations for protection. But let's start with this guy right here. We have the American porcupine. We all know something cool about porcupines, right? They have huge quills on their back, about 30,000 quills. You'll see some quills right here. This is from a different species of porcupine, but I wanted you to get an idea for how big those are. As you can see, porcupines are really good at climbing trees, and that's because they live in the forest. So they have to have another way of protecting themselves. They are nocturnal, which means they're active at night. Even though they're active at night, their sense of sight is pretty bad, but they make up for that with an excellent sense of hearing. Over here, we've got the 9-banded armadillo. I love 9-banded armadillos because they have a really hard armor that helps to protect them from predators. They're able to actually roll up into a ball like a transformer to help protect them. Now they can hold their breath for 6 minutes. That's crazy. Can you hold your breath for 6 minutes? Don't even try it. you guys. They have really sharp claws that help them dig into the ground because they live in burrows, and that's one place that they can hide. Now, like our porcupine, they are also nocturnal. And also like our porcupine, they're pretty bad at seeing. But they have an excellent sense of hearing and an excellent sense of smell. So which one's your favorite?
Wow, thank you, Amanda, for showing us those really, really cool animals. But I wonder, how much do these animals weigh? Well, we're talking about our armadillo friend right here. An armadillo will weigh around 9 pounds. But what's a good way to look at that? Well, if you wanted to think about that at home, imagine 36 sticks of butter just to equal that one right there. But what about our porcupine friend right behind me? How much do you weigh? Do you know? Doesn't answer me. What I know is porcupines, they weigh on average about 23 pounds. But in sticks of butter, how many sticks of butter would that be? Well, if I did the math correctly, that thing should weigh about 92 sticks of butter. That's a lot of butter. This is such a cool way to think about animals, especially when we think about how much they weigh.
Fun fact, a cheetah's claws are always out and its long, skinny tail provides balance for fast turns.
I spy with my little eye an animal from Colorado. Let's take a trip through the wildlife diorama halls here at the Denver Museum of Nature and Science and see if we can find some amazing animals. Our first challenge is to find the animal in this diorama with horns. Nice work, it's this pronghorn right here. Pronghorns are incredibly fast, an amazing adaptation. Let's try another. And for this one, I'll disappear so you can see it better. How many coyotes can you find in this diorama? One, 2, 3, 4, 5, and 6. There are 6 coyotes. And for our third and final I Spy challenge, in this diorama, can you find the butterfly? Look closely. I found it! Nice work, everybody. For our next activity, we're gonna learn even more about beautiful butterflies and the unique way that they grow. Let's check it out.
Hi, I'm Keelan McCarthy, a program specialist at the Denver Museum of Nature and Science. I'm working from home right now, practicing social distancing, but I made this video to demonstrate how we can explore nature from wherever we are. So today I'm going to be making a butterfly life cycle guide, which you could also make into a necklace if you have some yarn at home. So if you'd like to follow along and make this with me, you'll need some supplies. You'll need a paper plate divided into 4 for the 4 life stages. You'll need some yarn if you're going to make that necklace. Some leaf cutouts, which you could make yourself at home. And some glue. You could try a stick. I found that liquid glue actually worked much better. And some little pieces of pasta to glue onto your leaves that represent each life stage of a butterfly. So I have a chini de pepe, rotini, some shells, and farfalle. but you don't have to use those exact ones. And if you don't have any pasta to use at home, you can just draw them on and it'll look just as good. So let's get to the butterflies. Butterflies are some of my favorite bugs. You may not know this, but butterflies actually are bugs. They're insects. We define an insect as having 3 body parts, a head, a thorax, and an abdomen, 6 legs, which you can't really see on this model very well, and 2 antennae. And butterflies have all of those. But they don't always look just like this, do they? They go through a lot of changes before they become the adult butterflies that we recognize. And in fact, butterflies go through something called complete metamorphosis, which means they change completely from the time they hatch out of their eggs until they reach their adult form. And these are the life stages of a butterfly's complete metamorphosis. They go from an egg, itty bitty egg, to a caterpillar, to a chrysalis, and then they hatch out of that chrysalis an adult butterfly. So for butterfly eggs, I have a chini de pepe, which is pasta that is teeny tiny little dots. You could also use orzo or rice, or even just make little dots on your leaf to represent the eggs. What I like about this pasta is it actually looks just like butterfly eggs. Real butterfly eggs are round, they are teeny tiny, like the head of a pin, and they are off-white or yellow in color. So when you are searching for butterfly eggs outside on your nature walks, you can look in the middle, like right down the center of a leaf, or on the underside of a leaf for these teeny tiny little dots that look like that. So I'm gonna set that off to the side to dry. These insects are in their eggs for about a week or so, and then they hatch into caterpillars. And for caterpillars, I have a rotini. The reason we use a rotini is because it has little curlicues that look like segments, like the segments or parts, little parts of a caterpillar's body. A caterpillar is a caterpillar for about 10 to 14 days, and all it does for about 2 weeks is eat and eat and eat and eat and eat and also eat. If you remember the book, The Very Hungry Caterpillar, that's pretty much what it's like. They are storing up energy so that they can form a chrysalis and become a full butterfly. So you heard me say before that insects only have 6 legs, and you may be thinking, caterpillars have a lot more than that. And caterpillars, in fact, have 6 legs way up front. If you can see way up front, those 6 legs, and then they have a bunch of little kind of nubbins all the way back down that are called prolegs that serve the same function as legs, but they're not quite true legs. So this caterpillar is all full and ready to form a chrysalis. So for a chrysalis, which is also called a pupa, I'm using a little medium shell here. You could also use a macaroni, or you could draw something that's kind of teardrop shaped, because that's kind of the shape of a chrysalis. So our caterpillar will crawl to the underside of a leaf. It'll hang upside down, and it'll shed its outer exoskeleton, its outer skin, in order to form that outer casing for that chrysalis. And what's really cool is what's happening inside that chrysalis. So inside that chrysalis, that caterpillar actually is breaking down all of its body parts and kind of forming a jelly. It actually digests itself in order to form a whole new body. So all of that energy that it stored up from eating and eating and eating and eating for 10 to 14 days before this, it is putting all of that energy into becoming a brand new butterfly. So our chrysalis is going to hang upside down for about a week or so, maybe even longer, depending on the type of butterfly. And then, after some time, our butterfly will emerge. So for our butterfly, we have a little farfalle or bow tie pasta, because that bow tie looks like little wings that are coming out of its body. And we're going to glue this to a leaf, because when it emerges from that leaf, it'll hang out on that leaf for a little bit. When that butterfly first comes out of its chrysalis, its leaves are all wet and folded up. And it needs those wings to dry out before it can fly off and do its thing. So now that it is an adult butterfly, it can fly off, it can find a mate, and it can lay eggs of its own and start the whole cycle all over again. So now that we have all of our little parts, all of our little pieces here, we can glue them to our plate. And remember, the order goes from egg to caterpillar to chrysalis to butterfly. Or you can punch little holes in them right up near the stem or so and string them on your yarn. And one good trick to know, if you're going to do it this way, is to put it on the string and then make a knot. Then put the next one on the string and put another knot. That way they won't all kind of clump together when you're wearing it. So now that we have our super cool guide to the lives of butterflies, we can use this to go outside and make observations about our environment. So if you're able to get outside, you can look for butterflies in these different life stages. You can look for eggs, either down the middle or on the undersides of leaves. You can look for caterpillars, usually in big leafy plants, eating and eating and eating. You can look for chrysalis, hanging from the underside of leaves or branches, and you can look for butterflies. And here in Colorado, we have lots of butterflies. And I've pulled up some pictures of some of the most common butterflies you'll see this summer in Colorado. So we have western tiger swallowtails. They are big and yellow and black, really beautiful. We have cabbage whites, which are small and white or off-white with little black tips on their wings. We have monarch butterflies, which are big and orange and black and white. And these ones you will definitely see if you live near milkweed. Milkweed is what's called the host plant of monarch butterflies, which means they'll only lay their eggs on milkweed and their caterpillars will only eat milkweed. The reason they do this is milkweed is toxic to birds. So by eating all of this milkweed, they make themselves taste super gross to birds, so birds won't eat them. How cool is that? And finally, we have painted ladies. These are my favorite. They look a little bit like monarchs. They're orange and black and white, but they're more brown and they're smaller than monarchs. And we see a huge migration of these at the end of summer and beginning of fall.
Awesome work, you all. Don't worry if you didn't get to make a butterfly craft along with us today. You can always do it later. But for now, let's learn a little bit more about butterflies. One question I had was, who's older? Dinosaurs or butterflies? How long do you think that butterflies have been on Earth? 10 years? 100 years? 1,000 or 10,000 or 100,000 years? Turns out the oldest butterfly fossils that have ever been discovered are about 55 million years old. That's just a little bit after the dinosaurs went extinct. Or did they? Which of these animals is related to dinosaurs? The dragonfly? The shark? Or the parrot? If you guessed parrot, you're exactly right. Birds are sort of like living dinosaurs. They're very closely related. Let's learn more about the connection between birds and dinosaurs.
The Denver Museum of Nature and Science houses thousands of dinosaur fossils, including impressive mounts of the T-Rex, Stegosaurus, Edmontosaurus, and the long-necked Diplodocus. But one of my favorite dinosaurs stands only 4 feet tall, sports up to 6,000 feathers, and goes by the name Big Gobbler. "65 million years ago, an asteroid impact caused the mass extinction of behemoth dinosaurs like T-Rex, but many avian dinosaurs survived. Scientists think that size and metabolic rate helped small dinosaurs adapt to changing ecosystems. Today, these avian dinosaurs, which we know as birds, are the world's most diverse group of living vertebrates. With over 10,000 described species, you might say we are still living in the age of the dinosaurs. One of the largest living dinosaurs is the turkey. Wild turkeys can weigh up to 29 pounds, but the true heavyweight champs evolved just 500 years ago through domestication. The wild turkeys that escaped domestication faced other threats, including habitat loss from clear-cutting, agriculture, and wildfire. Even the turkeys in this exhibit faced a little habitat destruction when in 1966, a photographer's light set the foreground on fire. As the museum worked to restore the wild turkey exhibit, others worked to restore the wild turkey population. Habitat protection and reintroduction helped these avian dinosaurs rebound from near extinction. And the resilient birds lived up to the high expectations of Benjamin Franklin, who believed that the birds of courage would make a better national symbol than the bald eagle.
From T-Rex to turkey, a lot can change in millions of years. Let's make a few more comparisons between animals that lived a long time ago to the animals that live on Earth today. First, Dr. Ian Miller will talk to us about elephants from the Ice Age, and then Franklin will take us way back to compare two similar ocean animals that lived 100 million years apart.
Mammoths and mastodons are part of the elephant family tree, just different branches. They have a lot of similarities. They both look like elephants, but mammoths are much closer to living elephants. They have different ecologies. So mammoths are grazers, and they have very large, shallow-ridged teeth, whereas mastodons were forest animals, and they were browsers, and they had very high-ridged teeth for eating plants like twigs and bark and leaves.
Hi everyone, Franklin the raccoon host here, to talk about animals from then and now. I have two examples of animals that both live in the ocean. So these animals are really good for swimming around. They had fins and paddles to help them move through the water, but these animals still need to breathe air. This animal is a mosasaur. A lot of people know the mosasaur from the movie Jurassic World, but this one's a baby. So it's a lot smaller than the one that we saw. But here we could see on this jaw all the teeth that this mosasaur would use to capture animals to eat. Mosasaur had its nostrils here at the front of its snout, much like a crocodile or an alligator. This is different from an animal that we see today, like the dolphin. The dolphin is not a reptile, it's a mammal, and it still needs to breathe air. But instead of having its nostrils at the front, it has its nostrils here at the top. Why do you think this would help the dolphin when it's swimming around? The dolphin also has teeth meant to catch other animals so that it can eat, because this animal also likes to eat other animals just like a predator. Which one of these animals do you like?
All right, now I don't know about you guys, but in my personal opinion, the mosasaur is one of the coolest prehistoric marine reptiles to ever live. And it turns out they were also really big. Mosasaurs weighed about 30,000 pounds. But how many sticks of butter is that? 30,000 pounds. There's 4 sticks of butter in a pound. That's 120,000 sticks of butter, you guys. 120,000 sticks of butter. That is so many pies you could make. Now let's check out the dolphin. The dolphin is smaller. The dolphin weighs, on average, about 400 pounds. They can get bigger, but they can also be a little bit smaller. So let's say on average about 400 pounds. So how many sticks of butter is that? 400 pounds, 4 sticks of butter per pound. So 400, that's like 1,600 sticks of butter. So 1,600 sticks of butter and 120,000 sticks of butter. That's a lot of butter.
Fun fact, crocodiles have the hardest bite of any living creature.
Sometimes change happens relatively quickly, like when some ancient wolves met up with some ancient humans and over generations became dogs. Here at the museum, Jennifer is our resident dog expert, so let's ask her all about our canine companions.
Hi, everyone. Welcome back. This is Trelaw again. I am over at the Denver Museum of Nature and Science, and right now I'm joined by my friend, Jennifer Moss Logan. She's an educator here at the museum, just like I am, but she has been lucky to work on an exhibit all about dogs. So she knows a lot about those critters, but she's also a dog trainer, so she's doubly smart about dogs. So we're going to ask her a few questions today to tell us about that kind of animal. So my first question for you, Jennifer, is, do dogs sense the world the same way people do?
You know, Trelaw, dogs have the same senses that we do. They can see things, they can hear things, they can smell things, taste things, all of these senses that we have. But they have a different ability in each of those senses than we do. And the sense that they use the most is their sense of smell.
So they use it the most. How is a dog's sense of smell different than ours?
You know, to answer that, I think I'm going to bring in a special guest. And that is my little dog, Katie, who's right here. Here we go. Here's Katie. Can you say hi? Can you
say Katie, you're so cute.
Hi. What's this? What's this? Oh, yeah, you're so excited. So let's see if we can demonstrate this with Katie. I have right here in my hand a very delicious treat. She's very interested. So just in case you think they only use smell, you can see that clearly they use sight as well. And right here, I'm going to take this treat and I'm going to put it in one of my hands, but she's not going to be able to tell which one it is. Let's see what I can do. And we'll see if she can smell. Which one? Is it this one? Is it this one? Which one is it? What a good girl. Did you see that? She could smell which of my hands had the treat. And that's because
how does she do that?
Like dogs, has a very special nose. What's this, Katie? Can we see your nose? Can we see your nose?
It is a very cute nose.
So let's talk about that nose right there. Well, a dog's nose is shaped in a very particular way. And so that shape is, and for those of you who maybe have a dog at home, you can take a look at your own dog and look for the same thing. A dog has nostrils just like we do, but then they have these funny little slits on the side. And what that does is it allows a dog, when they take a sniff, they breathe in, and all those little scents go up into the nose through the nostril. And when they blow out the sides, out those little slits. So the smell goes in and out the sides and in and out the sides. And that allows them to pick up a lot more smell than humans do. Now, in addition to that, we all know that dogs have a cold, wet nose. And that's because that moisture on the wetness of the nose also helps to pick up smells.
So they pick up more smells, but when they are smelling a smell, is it the same as when a person smells a smell? Can they smell more and better?
That's also a great question. You know, I want to use an idea here, which is when you go home and you smell soup in your house, right? You go home and you know that somebody is cooking a delicious soup, and you might even know that it's maybe it's vegetable soup, and you can tell that. So when your dog smells the soup, your dog can tell that there are tomatoes and maybe some beef or some chicken and a little bit of some peas or carrots. Your dog can tell all the individual smells.
Wow.
What's more, if we took that bowl of soup 2 blocks away in your neighborhood, your dog could still smell that soup. So a dog can can smell the different smells, and they can smell from a lot further away.
What is it like for a dog when it's going on a walk?
So a lot of us think that we want to go on a walk with our dog to give our dogs physical exercise, and that's true. But do you know that there's another way that a walk can give your dog exercise? Brain exercise. And that is by going on a sniffy walk. Because we know that dogs can smell all sorts of things. So when they walk out the door with us, they have a whole world of smells and all sorts of stories that those smells are telling. So next time you go on your walk, try going for a walk and let your dog stop and sniff somewhere, maybe at a tree or a bush or a little bit of grass. And your dog is going to be smelling all those smells that tell a story. Maybe telling your dog what dog was there before and when. Maybe a squirrel passed by, or a fox, or a cat. Any of those things the dog can pick up in the smell. And you know, sometimes we're tempted to kind of pull our dog along and keep on moving because we want to get more exercise. But think of this, you might be interrupting your dog in the middle of reading that story through smells. So if you just leave your dog a little moment longer to finish that up, she'll have the whole story. And when she gets home, she'll be exhausted. She will have gotten exercise, brain exercise.
Jennifer and Katie both, thank you so much for joining us today. We really appreciate it. Hope that the rest of your day is great.
Great. Bye.
Bye.
So some animals are wild and need to be left alone, but others, like dogs, live right alongside us. Same goes for cats, horses, different birds, pretty much anything you would find on Old MacDonald's farm. Why is that? Well, here's our curator of mammals, Dr. John Dembowski, to talk to us about wild animals, domesticated ones, and even the ones that fall sort of in between.
Hi students, welcome back. This is Trelaura again at the Denver Museum of Nature and Science. You know how some animals are cuddly and cozy and the ones you want to hang out with at home, like maybe your dog or your cat or your guinea pig? And some animals are the opposite. They're the ones out in nature and you could not pet them or cuddle with them. Today, we're going to talk to one of the museum's scientists, Dr. John Dembowski, about what makes a wild animal wild and what makes an animal domesticated. And we'll talk more about that word in just a minute. So, hi, Dr. Dembowski. How are you today?
Pretty good. Hi, everybody. How are you doing out there?
Everybody should be saying at their TV screens, "We're doing great." That's my hope. So we all love animals. I presume we all love animals. I know I do. I know at home when I watch my pets, they certainly give me lots of love, and I like to pet them and play games with them, toss the ball for our dog, and wiggle yarn or light pointers for our cat. But that's not true of wild animals. Wild animals can be pretty unpredictable and oftentimes just want to be left alone. So Dr. Dembowski, as an animal scientist, what is a wild animal? Can you explain that for us?
Yeah, a wild animal, pretty simply, is an animal that finds its own food or shelter without help from humans. That's a good way to think about it. And typically they live in areas where they haven't been introduced to that area by humans.
So they're what we would call native to that place?
That's right, they're native. And another, and you've already mentioned this term, is we don't consider wild animals domesticated.
So as long as you've brought that word up, what does domesticated mean?
Well, probably most of the students are going to know something about domestication or domestic animals because they might have one living in their home, be that a dog or a cat or their guinea pig or maybe even a pet mouse or rat. Domestication or domestic animals are the result of a real long term, over thousands of years, relationship between humans and that animal. And what it really means is the humans provide the food and the shelter or other support for that animal. So in other words, think about cattle, cows, and sheep. They're not really pets, but they're domesticated. In other words, humans, we provide support for them. We provide them with food or grazing areas or even shelter. And we either get meat from them. That's kind of one of the reasons they were domesticated to begin with. Or in the case of cattle, it may be milk, you know, the milk we buy in the grocery store. Sheep, it may be the wool that we use to make a sweater with. So those aren't really pets, but they're domesticated because they rely on us humans to take care of them or provide that support, food and shelter. Domesticated animals come from previously wild animals. So the dog is the first animal that we know of to be domesticated by humans. And this is at least 15,000 years ago, if not more. And how that probably happened with wolves is you had humans living in settlements or areas, and maybe they were throwing their trash out or their leftover food. And wolves, our ancestors of wolves, were around in the area, and they came in, saw, hey, there's some food here. This is easy to get to. They tolerated at some level the humans there, and the humans tolerated them. And then once again, over years and years, hundreds of years, thousands of years, it was much easier for the humans and the wolves to get along. Humans also saw that the wolves provided them with some benefits. So maybe the wolves were good at telling them when other predators were around. So they were warning, they were good guards. Maybe the wolves helped them hunt too, the humans hunt as well. And they also provided some companionship, which we're all used to right now with our dogs in our house. But this process took place over a long time. And so here's where it also gets interesting. Many of you probably have a pet dog at home, and maybe it's a certain kind of breed. Maybe you have a Labrador, or maybe you have a Dachshund, you know, the little wiener dogs. But those only really came about in the last 200 to 300 years when humans really started saying, let's take these dogs and breed them for very specific purposes, whether it's hunting or working or actually just for the way they look. Like, let's breed a dog that's small so I can carry it around and it's a companion for me. So all these dog breeds that we see today have come about only in the last couple hundred years, whereas the whole domestication process of ancestors of wolves to dogs started about 15,000 years ago. And other animals that have been domesticated, it's been cattle, sheep, maybe 10,000 years ago, cats, maybe about 9,000 years ago. Horses are actually pretty recent. They're only about maybe 4,000 years ago.
That's incredible. Well, I'm certainly grateful to our human ancestors for working that out. With those wolf ancestors, I know it brings me a lot of joy to have a pet dog in my life. I suspect a lot of people out there feel the same way.
Yeah, me too. I've got a dog. He's Kipper. He's been around for 12 years, and you mentioned going out in the field as a scientist. Well, he's been all around the Western U.S. with me, so he loves to. He's slowing down now, but it's still that, he still has his wild side to him too, where he loves to go out. He loves to look for other animals out there, chases squirrels still, those kind of things.
That's great. I hope he's never had a run-in with a porcupine.
Well, here's a good story right here. about 20 years ago, I had 2 Alaskan Malamutes. So some of the students probably know they look like big huskies. That's because at the time I lived in Alaska. That's where I did my schooling, my graduate work. And I had these 2 Malamutes. One was 125 pounds, the other was 120 pounds. Big dogs, really smart, but willful, meaning they were stubborn, if you will. But over the course of the years we had them, my wife and I, they got into porcupines 3 times. So for being very smart dogs, they seemed to have a problem with porcupines. And it wasn't fun. They would get the quills in their nose and in their face, and they just never learned from that. So yes, I've had my experience with porcupines.
Sorry if I brought up a sore point. Sorry, the pun. Well, I'm curious. We've talked a lot about wolves and dogs. Are domesticated and pet cats come from?
Yeah, they're another great story too. Cats, they think the domestication process started about 9,000 years ago. And the ancestor of domestic cats is what's known as a wild cat. And that's a cat that's about the size of Colorado's bobcat that lives in Southern Europe, like Italy, Spain, Northern Africa, and the Middle East. So this was a cat that would have been around also in Egypt, say, because cats are tied to Egyptian culture as well. But anyway, about 9,000 years ago, this domestication process started, and that probably happened because humans, may have had settlements, and these wildcats were around. They were hanging out. They saw food, and the food was rats and mice that might have been attracted to, say, storage of food by the humans. And so the humans at the time said, hey, these wild cats are good at ratting and mousing, in other words, getting rid of the pests that come in to get the grain or the other foods. So they tolerated the wildcats coming in. The wildcats got a meal out of this, and also tolerated the humans. And over time, a bit of a relationship started there.
So I'm curious now. Talked about domesticated animals and animals that are pets for us, and you've defined those as animals that get some of their care from people, but are there ways for people to care for wild animals?
Yeah, so you bring up a real interesting thing there. And also I'll get into, sometimes people say, oh, the wild animals tame. And tame's an interesting term. So, around in our backyards and in our parks, we see a lot of animals that are wild. They don't need us to find food or shelter, but they'll take advantage of food and shelter if they can find it. So things like squirrels and raccoons that are in our neighborhoods here in the greater Denver area. Those are wild animals. Are they tame? Somewhat. There's actually a fancy, and I'll do this, here's the one fancy scientific term I'll throw out there, and that is synanthrope. So that's spelled S-Y-N-A-N-T-H-R-O-P-E. And so that's a fancy term that just means together with humans. And that is a term that's used to describe wild animals that you could argue tolerate humans, live among humans. So we have a lot of urban wildlife, those animals that live among us in our neighborhoods. They take advantage of the food and shelter, but they also could live without us if they had to. So there's a lot of that. Some of them can get very accustomed to humans, particularly when we feed them. So you might go down, you might notice if you go to a park, some of the squirrels are pretty, they'll come right up to you and be looking for food. And that's probably because they've been fed before. So they're used to humans and they know, hey, there's a human, that human might have popcorn or part of their sandwich to give me. So they're somewhat tame in that respect, but they're not wild. They're still wild and they're not pets. And actually squirrels don't make the best pets anyway. Sometimes people have them as pets, but they're not really domesticated like dogs or cats. Here's another one. You might have a bird feeder in your backyard and wild birds come to it. So they take advantage of the free meal you're putting out there, or maybe you have a water bath and they'll take advantage of the water. But they're still considered wild animals. They tolerate humans. You might be able to walk up pretty close to them. Sometimes people are able to feed some of these animals from their hand. And so they're a bit tame, but they're still wild animals. So they're not domesticated. It's a different thing.
Well, thank you so much, Dr. Dembowski, for teaching us all of these things about domesticated, wild, tame pets. Woo, it's a lot to think about. Really appreciate your time, and have fun researching all of those animals out there in nature so we can learn more about them in the future.
Yeah, it's always fun. That's what I get to do, study the wild animals. I study wild animals.
Okay, I don't know about you, but I just learned a lot about animals. I'm also ready to switch gears from listening to making. So let's kick it over to my friend Harley for do-it-yourself bird feeders. After that, we'll catch up with Amanda and Franklin for our fourth and final animal spotlight.
Hi, welcome to Do-It-Yourself Bird Feeder with Harley.
For our bird feeder craft today, you will need oranges, raisins, peanut butter, oats, bird seed, and pine cones. I would suggest a cutting board, a knife, some extra spoons, a couple extra plates, and an extra empty bowl. Plus, you're going to need twine, string, yarn, one nail, and some scissors. Let's make some bird feeders.
So to begin, you're gonna take an orange and you're gonna cut it in half. As you can tell, these are not equal halves.
So you're gonna take your orange and you're gonna scoop out the fruit part. Oh, okay, grab your extra bowl and do it over your extra bowl because it's really juicy. A nail, and we are going to poke through the sides. I just put that one, okay. Boop. Then you're gonna grab your yarn and scissors. Okay, so we're gonna put our string through the hole and we're gonna tie it. Boop. Do a little extra one so that it stays secure. And we're gonna do it on this side. Put a little double knot again. There you go, see? If you want, you can use your scissors to trim these little bits off. That, we're gonna do it on this one too.
So next we're gonna grab that bowl that we put the innards of the orange in, and we are going to grab our raisins and put like a nice handful of raisins in there. Mine are all stuck together, so I'm gonna suggest breaking those up. Next, we're gonna grab our oats. Same thing, put a happy portion in there. Really up to you, however you like your bird food. And then we're gonna put in some peanut butter. Give it a good scoop. Then you wanna stir all these ingredients together. Just like that. And then you're gonna grab your bird feeder, right? And we're gonna scoop it in. Boop. Just fill it up. Oh. Yeah. Okay, so we have these cute bird feeders. Oop. I'm gonna put them on our cute little plates. And I'm gonna go clean up before we start the next one. Hi, welcome back to Do It Yourself Bird Feeders with Harley. Our next bird feeder is a little simpler than our first one because we're not going to make the bird food that goes inside. We're just going to use bird seed, pine cones, and peanut butter. You might have made these when you were a kid, but they are not out of date yet. So I'm gonna pick my favorite pine cone. This one's a good one. I'm gonna grab my twine, string, or yarn. And I'm gonna just kind of wrap it around, get it in there. So now that we have our twine on there, tuck that in, we're gonna start putting peanut butter on it. You just wanna get a nice little layer of peanut butter. So next, we're just gonna grab that bowl that we were using to make our own bird seed, just to kind of have something we can toss over. We're gonna grab our store-bought bird seed mix and just start to sprinkle it on there. Sprinkle, sprinkle. Nice, good job. And then we are going to have our second type of bird feeder, just like that. Put it on your plate. Let's go hang these up. Thank you for joining me for Do-It-Yourself Bird Feeder with Harley. Have a great rest of your night.
Hey, it's Amanda, your chipmunk host, back for our last animal spotlight. Now, there's nothing quite like the battle between cats and dogs. Do you guys have a cat or a dog at home? Let's check out a dog skull. This is actually a wolf skull, all right? Wolves have excellent vision and they have really good hearing. Check out these really sharp canines right here. They use those to help them tear through other animals. The other cool thing about wolves is they're pack hunters. They work together to find food for the group. Now, if we switch on over here to our tiger skull, do you see something that they have in common or something that they share? Look at these really sharp canines. They look a lot like our wolf skull, but these are a lot bigger. Tigers have really big teeth and they have really sharp claws to help them catch their prey. They also have really big paws to help them walk through the rainforest nice and quiet so they can sneak up on their prey. That also means they're really good at swimming. Those big paws help them to move through the water really quickly. Now, when you picture a tiger, what does the tiger look like? Yeah, it's got stripes, right? Those stripes help the tiger camouflage in the rainforest as it's trying to sneak up on its prey. So, which one do you like? Are you a cat person? Are you a dog person?
Thank you, Amanda, so much for showing us that really, really cool tiger and wolf. Now, when we think about tigers and wolves, I know that they're big, but how big? Do you know how much a tiger would weigh? Well, on average, a tiger weighs about 500 pounds. But you know what? I don't really know how to look at 500 pounds. If I wanted to, I could put in the sticks of butter, and that would be about 2,000 sticks of butter. Where would you even put 2,000 sticks of butter? That's a lot of butter. I don't even think a fridge can hold that much butter. Now, when we're talking about a wolf, though, wolves on average can weigh about 150 pounds, which in sticks of butter goes to about 600 sticks of butter. That's still so much butter. You could probably survive forever on that much butter. What a really, really cool way to think about how we measure animals. Measurements really help us make sense of the world that we live in and really helps us understand the animals or the things that we study.
Today, we've been using butter to help us think about how heavy things are. But it made me realize something. Butter is also an example of another way we connect to animals. Like cheese and yogurt, butter is made from milk, which comes from cows. People all over the world use ingredients we get from animals to make food and other products too. So we've got one more activity for you to try. This time, Amanda's going to help us make butter at home.
Hey everybody, it's Amanda here. We've been learning a lot about domesticated animals, and we can use those animals to make products like food and fabric. So we eat eggs, we eat meat, we drink milk, right? We also wear wool clothing sometimes that we get from animals. So I'm going to show you something that we can make from heavy whipping cream, right, which we get from cows. And we're going to be making butter today. So all you'll need is heavy whipping cream and then a container with a lid. So I'm using like a mason jar. So you're going to take some heavy whipping cream. You're just going to pour, I don't know, like a half cup, a cup in there. And then you're going to want to make sure you put the lid on nice and tight. Okay, so screw that on nice and tight, because once you start shaking this, we do not want this to explode everywhere. All right, and while we all love a good explosion, this is not stuff that we want to explode all over the place. So you're going to be shaking a lot. This is actually something that I did with my family when I was a kid that kept us busy and it kept us out of the kitchen. So my parents would always make us do this. So you're going to take your jar of whipping cream and you're just going to start shaking. So what's going to happen to make butter is the fat molecules in our whipping cream, when you start shaking them, they kind of freak out a little bit. So we start to like agitate them, we call them, or stir it up. And when those fat molecules freak out, they want to grab onto the thing that's next to them. And that's another fat molecule, all right? So we want those fat molecules to grab onto each other So we're gonna shake it really, really hard. Now guys, this doesn't happen right away. Sometimes we gotta shake it for a really, really long time. Your arms are gonna get tired, and that's why it was helpful to have 3 other siblings. So I had a brother and 2 sisters who could all help me make this. That's probably why my parents did it, because there were a lot of us. So we're gonna shake and shake. Whew, I'm starting to sweat already. It's warm in here. Shake, 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 shake. I'm singing a little song in my head, trying to shake to the beat. All right, whew. Guys, I am tired. I'm gonna take a little bit of a break, and I'll come back and get it later. All right? I think I'm ready to shake again. Man, it came in real handy having brothers and sisters. Now I gotta do this all by myself. Huh. Let's check. Whoa! Not bad! I mean, I got some pretty good muscles, right? Check it out, guys. Got this butter all clumped up. We've agitated those fat molecules enough that they've grabbed onto each other and gave us that really creamy butter. Now, guys, this is something that you can do at home. You can even change it a little bit. You can add honey to it. You can add cinnamon and sugar to it. You can add herbs like dill, all sorts of different butter creations. Check online. You can see all different butter creations. All right? So, something you can do with your family, your brothers, and your sisters, if you're constantly in the way, which I was, always. All right, guys, see you later.
Hi, everybody. It's Trelaure again over at the Denver Museum of Nature and Science, and I am back today with our friend Evelyn, the manager of the education collections here at the museum. Today, we've been talking about quantifying. That means measuring and weighing and looking at objects by numbers that we can give them. When we know how tall something is, how much it weighs, how many examples of something there are, it helps us when we do our comparing, when we're doing science. And so we thought it'd be fun to go into our education collections with Evelyn and put some numbers on our objects. Please tell us, what is the tallest object in the education collections?
So the tallest object we have is the Delta IV rocket that used to be hanging in Space Odyssey. And it's about 25 feet long, but it is here in storage. And you can see it takes up quite a bit of our storage space. So it's in 2 pieces right now.
That is very big.
It's in 2 pieces right now. But when you put all of that together, it's about 25 feet long. And it takes a forklift to get it up here.
Wow. Wow, you bring a forklift into the building? That's amazing. All right, so let's think about that. A stick of butter is about 5 inches long, and that rocket, when it's put all together, is 25 feet long. And so if I stacked sticks of butter end to end, 60 of them would reach 25 feet. So 60 sticks of butter tall for that rocket. So that's our tallest in education collections. Let's move on. What is the heaviest thing you have in education collections?
So the heaviest thing, I think, is we have a hadrosaur footprint from the western slope of Colorado. And this is used.
So a hadrosaur is a type of dinosaur.
So that is a hadrosaur from a coal mine on the western slopes of Colorado, and it's about 450 to 500 pounds.
So this hadrosaur dinosaur was walking along and it left its footprint in the ground, maybe in some soft sand or mud, and then that got filled.
So the dinosaur stepped in some like soft mush, some maybe plant material. That stuff became the coal, and the coal miners dug that out. But when the dinosaur stepped in that mush, later on some sand and silt washed in over it, and it filled in that footprint. So what you're seeing is kind of a negative impression of that footprint. So it steps, but then that filled in. So this is solid stone. This is sandstone.
And so you're saying that weighs up to 500 pounds. So I figured out that to understand 500 pounds in sticks of butter, I would need 2,000 sticks of butter to make the same weight as that one fossil footprint that you have there. Do you need a fork? Do you need a forklift to move that fossil?
No, we have it on dollies, and we push it, either push it or we pull it with a rope. It's a good workout.
Nice.
That's how we start our morning.
So for kids who don't know what a dolly is, it's a special kind of cart that has wheels on it.
Yes.
All right, I think we've done collections by the numbers. We've done collections by the butter sticks. Evelyn, thank you so much for your time today. As always, it was so fun to see you, and we'll talk to you later.
Absolutely. Bye.
Bye.
It all started when I was a little kid. I was probably 8 years old. And one day I just realized how weird it was that we live on this one planet in the solar system, maybe in the whole universe, that had life on it. And I was so intrigued with that idea, so perplexed. And I thought to myself, well, if I want to understand that better, maybe I should study that. And I thought, well, what is life but nature? So I thought, okay, I'll do that. I'll study nature. And so I remember distinctly going to one of my older siblings, it was my brother, one of my older sisters, and I asked him, I said, is there a word for a person who wants to study nature? And my siblings said, well, yes, naturalist. And they looked it up for me in the dictionary and showed me that word. And I was amazed that someone had thought of this before me. I thought I was coming up with it for the first time. But from that point on, I thought to myself, that's what I want to be. I want to be a naturalist.
When I was growing up, I was always outside playing in the dirt. And when I started to find weird-shaped rocks and sometimes even fossils, I was hooked. I knew that I had to be a dinosaur digger for my life.
I got really into archaeology as a kid, but it really didn't start specifically with archaeology. I grew up on the beach in New Jersey, and I spent every summer looking at the rocks and looking for all kinds of little critters and shells and sand dollars, and just observing and paying attention to what those life forms were in the rocks. And then I got really excited about digging, and I would always try and dig the deepest hole and get really excited if things were inside the hole. Like, you know, sometimes I found somebody's flip-flop or a coin, and it just really ignited that curiosity in me to learn more about what people leave behind and how we can discover all different things about humans and what we did in the past just by the stuff that gets discarded and trashed.
I had kind of an unusual upbringing. I grew up on a ranch in the middle of nowhere in Canada. And so I went to a one-room schoolhouse in a horse and buggy, and I probably didn't know anything about fossils when I was a kid. But one day when I was about 12 years old, a friend of my father's came to our ranch, and he asked my father if I could go with them to go fossil hunting. And I didn't know what that was, but I went with him, and it was so exciting because I found some fossils. In fact, I found this fossil right here. I still have this from when I was a very young boy. And this is a vertebra from a duck-billed dinosaur. And it just fascinated me because I looked at it and I saw the holes in it and I thought, there must have been blood vessels going in there. And it really created an imagination for me. So that's really what got me started in paleontology.
My dad's side lived in Potomac River area of Virginia. So when I used to go visit them, they lived in their backyard was a stream, or part of the Potomac River was right there. So it was knee deep, if you will, in nature. Probably the other influence was my other grandfather on my mother's side had a farm in southeast Kansas, and I used to go out and visit during the summers. You know, so he raised cattle, he had wheat and soybeans. So I used to go out there and really enjoyed that.
I didn't always know that fossils and geology was my thing, but I always knew that science was my thing. I feel like I've always been a scientist, and that's mostly because I just love observing, like observation, and that's such a key component of doing good science. During like late elementary school, I would breed ladybugs. I'd spend hours outside catching as many ladybugs as I could and putting them in a jar based on their color, and I would like learn how to tell what gender they were. Would keep the little pregnant females until they laid their eggs and raise their babies, which it takes a lot of work because baby ladybugs eat a ton of aphids, and I would every day would have to go out and catch so many aphids. Every day, opening every jar, feeding them like a leaf covered in aphids, learning about inheritance and evolution. Eventually, it led me back to a very deep time. Like how all animals evolved, and that's kind of what really led me into paleontology.
So I grew up in southwestern North Dakota, which is sort of in the middle of nowhere, but it's right in the middle of dinosaur country. And some of my earliest childhood memories are of me running around the Badlands looking for fossils. And so I started to have these questions as a child when I was finding these cool dinosaur fossils and these cool turtle fossils that aren't there today. So it was really getting outside and finding these amazing fossils, and just looking at the rocks and everything around me, where I started to come up with these questions. I was just very, very lucky to be living right in dinosaur country.
One of my favorite childhood experiences was going to the library with my mom and my younger brother once a week or once every other week. It was just so much fun to explore the library and go to the bookshelves and feel the new pages and the wrappings on the books, and just to explore what interested me. One of my favorite things to do was to go to the new bookshelves and see like what was the newest book they got in, because that was something exciting. It was new and exciting. I don't have a favorite book in particular, but what I did was, if I found a subject I was really interested in or an author I really, really loved, I would go find the rest of the titles written by that person, or I would go to the section with more books about that subject. I also really loved hanging out with my mom, because we would go to the needlework section or the cookbook section, and I would explore with her. In my role as a collections manager, it's like being a librarian, kind of, but instead of for books, it's for objects. Part of my love for organizing and databasing things is because when I went to the library, I would go through the card catalog back when it was still paper, and then later, as they developed computer databases, I would get really good at finding different ways to search for books and subjects, and I really love developing those skills. I think libraries are great. The adventures are limitless with whatever you decide to choose to read.
Well, friends, that's about it for our exploration of all things animal. I hope you had the best time observing, questioning, measuring, grouping, and comparing, just like the scientists you are. Until next time, from all of us at DM&S, see ya!
What does it mean to be a good citizen?
To be kind, be safe, do your job, and show initiative. Help others. It means helping your parents and helping your family and doing what's right for you. When they see something wrong, they do the right thing, like taking turns and sharing what they have and working together.
That's right.
Well, if you're a good citizen, you're kind to others. It means to help people. Be kind to every person, even if you don't know them. Take care of our community.
Great answers. What can you do to be a good citizen at home, in school, and in your community? Presented by Shalott Hatton and Banker, Colorado lawyers inspiring the next generation of great citizens.
We have an opportunity for those of us who are able to work from home right now to pour into our kids more than we normally get to.
I get to have this opportunity to pause and be still and smell the roses, for lack of better words, within our own home.
All my parents out there, y'all are kicking butt.
We will get through this, and our children are going to be one of the things that actually helps us make it through this.